Hello everyone. Today I am going to discuss the second problem of Leetcode Weekly Contest 435, which is maximum Manhattan distance after k changes. So we are given a string S with four directions n, s, e, w. So index I will represent one direction n, s, e, w. Okay. So we will be initially at 0, 0 position, and we have to follow the direction according to si. And we are also given some value k. So we can change at most k characters in the direction string, and after that we have to find the maximum Manhattan distance we can achieve from 0, 0. Okay, so let's take the first example. What is the first example? First example is NWAC. Okay, so let me write it here. Our first example is NWAC. So initially we will be at 0, 0. Initially we will be at 0, 0, and when we are at some index 0, so we will go to north. North means our uh, y coordinate will be decremented by 1, so we will be at minus 1, 0. And again we are achieving one west. West means we will decrement our x coordinate by 1. Okay, so this will be 0, minus 1, 0, minus 1, because y coordinate is decrementing for north, and for west our x coordinate is decrementing by 1. Now for south our y coordinate will incremented by 1, so this will be minus 1, 0. And for east our y coordinate will incremented x coordinate will increment by 1, so this will be 0, 0. So from 0, 0, we again got to 0, 0. So we have to find the Manhattan distance. Manhattan distance is nothing but modulo of x2 minus x1 and plus modulo of y2 minus y1. Okay, modulo of x2 minus y1 and modulo of y2 minus y1. Now for the first example, what is our k value? K value is 1. Okay, k is 1. That means we can change at most one character in this string. So let's say we change the second character. We can change the second character to, let's say, e. Okay. Yeah. We can change the, let's say, the second character to e. Okay. Okay, no, let's say we change the first character to s. Let's say we change the first character to s, so our string will be s w s e. Okay, now we are at initially 0, 0, 0, 0, and after getting south we'll be at 0, 1. After getting west we'll be at minus 1, 1, and after getting south we'll be at minus 1, 2, and after getting east we will be at 0, 2. So at any point our maximum Manhattan distance will be at this point. Our maximum Manhattan distance will be at this point, which will be modulo of minus 1 plus modulo of 2. So our maximum Manhattan distance will be 3. So this is one transformation we can do, or we can change this NWAC to NWNE also. That will also be a candidate for maximum Manhattan distance. Okay. Now, how we are going to solve this problem? The brute force way to solve this problem is take any k characters, any k character we can take using 2 to the power k and change it to any four direction. So the problem is solvable using brute force using 2 to the power k. Uh, we are choosing any k character 2 to the power k and changing this k characters to 4 characters. So 2 to the power k into 4 to the power k, that is the brute force solution I can think of. So, but let's not go into this brute force solution. So now let's come to observations. What observations we can make? The first observation we can make is that this north south is dependent on each other. So we don't want to have something like north and south back to back. We want to have north and north, and south or south and south. Similarly, north and south is not also dependent on east and west. We can solve the problem separately for north south and east west, that they are not dependent on each other. Okay, now another, this is the first observation, that we'll try to have the same type of characters. We can have NN, we can have SS, or similarly we can have east east, and we can have west west. Now here you can check that we are just changing the value from prefix. That means let's say we have some string like a n s n n n. Okay, and we can change any two characters. any two characters. We can change any two characters. So instead of changing the last two characters, the first changing the first two characters will help us. So we'll try to change the characters which are at the prefix only. Okay, because by changing the character at the end, we are just taking the negative impact of these two characters. We'll try not to take the negative impact of this two character, because we can just ignore the last two characters, right? We can just ignore the last two characters, and we'll try to generate positive impact from the first two characters. That's why that is important, that we'll only try to change the first k characters. Okay, we'll try to change the first k characters. Now what we can do, for let's say we are at some index I, we'll check that what are the count of north and the count of south. Okay, now what is the minimum between these two, we'll try to change that number of n to s. Okay, let's say n is minimum than s, so we'll try to change all the n's to s, all the n's to s. Similarly, after that, let's say a total number of operations are k. Okay, and our minimum value of this north and south is p. Okay, so we have changed p ends to p souths. So after that, k minus p operations are remaining. Similarly, we have something like east and west. We are solving this separately. So we will take the minimum of east and west, and let's say that our minimum is east. So we'll change k minus p east to k minus p west. Okay, and after that our desired answer will be the total number of norths minus total number of souths, the difference between them, and the total number of east and west, the difference between them. That will be our desired answer. So we'll iterate over every I index from start to end. We'll try to count north, south, east and west, and we'll try to perform k operations at a specific index. So let's jump into the code, you will understand it better. Okay, so d is our frequency array. So we are maintaining the frequency of north, east, west, south till this index I. Okay, so we have found our count of east, count of west, count of north and count of south. Now our current result is the absolute difference between east and west, and the absolute difference between cn minus cs. This race is without any operations. Okay, now p is our minimum of k comma ce comma cw. So we'll try to change k easts to wests, or p wests to easts. So the minimum between c, cw and ck, k will be the operations we are doing to east west pair. Okay, and similarly q is the remaining number of operations, or the minimum of cn comma cs. Okay, so we have got our p comma q. So we'll try to change p easts to west, or wests to east, or we have something like q number of operations. So we'll try to change q south to north, or north to south. So when we are changing some east to west, uh, so let's say we have 3 east and 1 west. Now we are changing the resulting value is 3 minus 1 2. So let's say we are changing 1 west to east, so we are generating 2 impact, so we'll be adding plus 2 to here. Okay, that's why uh, after we have found p and q, our resultant answer will be result plus 2 into p plus 2 into q. Okay, I hope you are getting it. So when we are changing east to west, we are generating plus 2, and similarly when we are changing to north to south, we are generating plus 2. I hope you get. The problem is quite straightforward, just observations are required. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I will try to reply each and every comment. And if you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.